Good morning. Today we'll be studying the theory of KTG. So let's start with the history. So in 1738, Daniel Bernoulli published Hydrodynamica. In this book, he laid the basis for the KTG, and in this work, Bernoulli posed the argument that gases consist of great number of molecules which move in all directions, and that their impact on the surface causes the pressure of the gas, and that their average kinetic energy determines the temperature of the gas. Other pioneers of kinetic theory, whose work were largely neglected by their contemporaries, were Michael Lomonosov, George Louis Lesage, John Harrap, whose image we don't have available, and John James Watterson. So the contemporaries connected their research with the development of mechanical explanations of gravitation, and these guys' work was overshadowed by those contemporaries. Now that's a bit of history. Let's start with what is KTG. So it's a classical model of thermodynamics. So it's a classical model of thermodynamic behavior of gases, and through this many principal concepts of thermodynamics were established. So the second point is principal concepts. Next is it explains the macroscopic properties of gases. So macroscopic properties are explained by this, and it also accounts for related phenomena such as Brownian motion. So accounts for related phenomena. Now let's go ahead with the assumptions made by the KTG. So every theory has several assumptions. In this one, the first assumption we have is that the gas consists of very small particles, that is, the sum of the volumes of individual gas molecules, like these gas molecules, if we keep them together, this whole thing would be negligible compared to the container of the gas. This also means that the distance separating the gas particles, this distance, is really big compared to the size of the particles, and that the time of a collision between particles and the container's wall, this particle and the container's wall collision, this time is negligible as compared to collision between two particles. So because particles are really small, there is the time taken for two particles to collide would be way greater than the collision between particles and the wall. Now the next assumption is the number of particles is so large that we can use the statistics on the problem, and the use of statistics is well justified. So this assumption is sometimes referred to as thermodynamic limit. That is, we have way too many particles here, so we can use statistics. So third point is the rapidly moving particles constantly collide amongst themselves and with the walls of container. So because these are constantly colliding with each other and the container, so this assumption would be that this collision and this collision is elastic. That is, that no energy is lost during the collision. This also means that molecules are perfect Hart spheres. And next we have fourth assumption, that is, except during the collision, interactions among molecules are negligible. So other than when they are colliding, we don't assume that they are interacting with each other. That is, they exert no other forces on one another. So these are the assumptions. That was a brief history, and this was what kinetic theory of gases is.